AAR and CFUR are call forwarding special cases. AAR and CFUR are low-hanging fruit. We can make most AAR and CFUR work with little effort. AAR and CFUR are call forwarding special cases. Call forward no bandwidth, CFNB. Forward the call via the PSTN if there is no bandwidth for an internal call. This is also called Automated Alternate Routing, or AAR. AAR is always configured by the administrator. And call forward unregistered, or CFUR. Forward the call if the phone is unregistered. For example, CIPC is not running, a phone is unplugged, or the remote site has experienced a WAN failure. CFUR can optionally be configured by users. All these do is increase the chances that a call will complete by forwarding calls that would otherwise fail to different numbers. Automated alternate routing forwards the call via the PSTN if there is no bandwidth for an internal call. If we have no bandwidth to get to Winnipeg, then we route via the PSTN to get there. AAR configuration has these components: a dial plan component, what patterns to use to make the PSTN call and any restrictions we might place upon them, what gateway to use, and any digit manipulation to apply. A connection admission control, or CAC component, the bandwidth we have available for calls between sites. And a device configuration component, how we apply the dial plan and CAC components to devices. The Enterprise 20 dial plan build considers the patterns to use to make the PSTN call and any restrictions placed upon them, and what gateway to use, and the digit manipulation to apply. Uses a basic CAC component to test the dial plan build and facilitate rollout of device pools. At each site, we configure a location to use to assign the bandwidth we have available for calls between that site and other sites. And a device configuration component. We apply the dial plan and CAC components to Enterprise 20 devices. We will develop a more sophisticated CAC component later. Right now, we want to complete the dial plan build. AAR prefixes the external phone number mask of the called party with a value determined by the Automated Alternate Routing Groups, AARG, of the called and calling parties. We have 10-digit external phone number masks and will always prefix 91. We'll have a single AARG named NANP AARG because all of our phones are in the NANP. This works everywhere, except where sites require local calling for calling between them. Here are the Enterprise 20 sites. Enterprise 20 has sites that require local dialing for calling between them. Between Ashbridges Bay and Toronto downtown, between Toronto and Oakville, and between Oakville and Hamilton. It's not hard to figure this out. You can use the local calling guide for this. We showed you how that worked in the no delayed dialing drawing. We'll fix this using global called party transformations. We built called party transformations in Enterprise 20 dial plan build, outgoing digit manipulation. The Ashbridges Bay, Oakville, and Hamilton sites all use the called-X discard 9 calling search space to apply called party transformations. We'll customize this calling search space to address AAR. At Ashbridges Bay, we need to discard the 1 and the 9, of course, for routing to the Toronto site with NPA NXX 416-555. We need to discard the 1 and the 9, of course, for routing to the Oakville site with NPA NXX 905742. We will use a site-specific calling search space, ABay691, called-X calling search space. What about the Toronto gateways? We have a SIP trunk using E.164 and a PRI with ISDN type of number. We don't have to do anything for SIP trunk using E.164. The transformations we use to globalize numbers work great. Score 1 for E.164. For the PRI with ISDN type of number, If you can send local numbers as 10-digit numbers with type of number set to national, then we don't have to do anything. That's how these numbers will be sent. The transformations we use to do this work great. If we have to drop the 1 and flag the number as type subscriber and maybe apply the mask XXX, XXXX, then there's work to do. If we have to drop the 1 and flag the number as type subscriber, then we need a site-specific calling search space with the appropriate transformations. Here are the transformation patterns we need for the 10-site Enterprise 20 deployment from the Called Party Transformations tab on the delayed 7-digit dialing configuration information spreadsheet. The last 3 items in the table provide the patterns needed to implement tail-end hop-off at the Toronto site. We'll discuss tail-end hop-off later. We'll apply these transformations by configuring the site gateway device pools with the site-specific transformation calling search space. For example, for the ABay691 site, we use the ABay691 called X calling search space. For the CAC component, we created a location for each site with the bandwidth to the Hub None site set to unlimited. The bandwidth available between sites will be unlimited. When testing, we'll set the bandwidth between sites to 24K to allow a single G.729 call, or 8K to allow no calls at all. Let's test it. We'll use the Halifax 696-7751 as the destination and call from Winnipeg 602-4001. First, we'll call Halifax 696-7751 using the long-distance pattern 91-902-696-7751. You can see from the caller ID 8602-4001 that this was placed as an on-net call. That's because of our off-net to on-net translation patterns. That's a problem for AAR. Let's put the off-net to on-net translation patterns into the no access partition for testing AAR. We'll call Halifax 696-7751 using the long-distance pattern 91-902-696-7751 again. You can see from the caller ID 91-204-555-4001 that this call was routed through the multi-site PSTN simulation. We'll configure the link between the Halifax 696 and Winnipeg 602 locations for 24 kilobits per second. We'll try to make 2 calls from Winnipeg 602-4001 to Halifax 696-7751 before AAR is configured. The second call is rejected with the error network busy. We changed the text from not enough bandwidth. Now we'll configure AAR. For devices and device pools, we'll configure AAR group, NANP AARG, and AAR calling search space, XXX unrestricted no 911 calling search space. Note, locations are configured only on device pools. For lines, we'll configure AAR destination mask, the same as the external phone number mask, and AAR group, NANP AARG. For example, at the Halifax 696 site, phones are configured like this. For the call manager service parameters, out of bandwidth text, network busy. AAR network congestion rerouting text, network busy rerouting. And automated alternate routing enable, true. We'll try again to make 2 calls from Winnipeg 602-4001 to Halifax 696-7751. Here's the first call. Our second call is still rejected with network busy. Why did the call fail? We can see before AAR was invoked in the trace. We can see the number used to route to the PSTN after AAR is invoked. We can see the right pattern matched for routing to the PSTN. We can see the rerouting message sent to the phone. And we can see that we are going to use the local route group of the last redirected party for the call to 91902-696-7751. Can you see why the call failed now? We are using the local route group of the last redirected party. The last redirected party was Halifax 696-7751. We were redirected because there wasn't enough bandwidth to get to the Halifax 696 site. The local route group for Halifax 696-7751 uses the Halifax 696 SIP trunk to route to the PSTN. But the Halifax 696 SIP trunk is also at the Halifax 696 site, and we haven't got enough bandwidth to get to that site. Using the local route group of the last redirected party complicates AAR implementation. What should we do? Stop using the local route group of the last redirecting party? As discussed earlier, that makes call forwarding behavior bizarre and unpredictable for users. We wouldn't do this just so that we can marginally increase our percentage of completed calls with AAR. Or adjust our dial plan? Is this practical? We'll have a look. We'll adjust the dial plan so that AAR calls will always route out the original caller's gateway. We can do this by adding a pattern at each site to specifically route out that site's gateway. Exclamation mark matches any number. XXX PSTN gateway partition, a site-specific partition, and XXX PSTN route list, a site-specific route list. The site-specific route list contains the route group for the site, which is already configured, and optionally the standard local route group. Including the standard local route group lets us use this route list for tail-end hop-off. We'll have a site-specific calling search space for each site containing the site-specific partition for the patterns we added. We'll configure the AAR calling search space on devices with the site-specific calling search space. We'll configure the AAR calling search space on device pools with the site-specific calling search space. Note, with these calling search spaces, we don't have to worry about our off-net to on-net translation patterns. We can put those back into the internal partition. We'll try again to make 2 calls from Winnipeg 602-4001 to Halifax 696-7751. Success! So is AAR worth it? You need this for each site. 1 extra partition, 1 extra calling search space, 1 extra route list, 1 extra pattern, and depending on the kind of gateway, called party transformations for sites that are local to each other. These will be more or less complicated depending upon the topology of your enterprise and your gateway protocols. It could be very easy, or it could be a lot of work. For Enterprise 20, this was easy. Enterprise 20 did the work to implement AAR. We think this is low-hanging fruit. What about CFUR? Call Forward Unregistered has 2 applications. For WAN failures at local sites, calls to lines at the site can be forwarded via the PSTN, similar to AAR. This needs to be configured by the administrator. We refuse to explain this to users, and it doesn't work anyway. And for phones that are not logged in or plugged in, calls to lines can be forwarded to voicemail or other internal or external numbers, for example, cell phones. This can be configured by the user. We can explain this. For WAN failures at remote sites, phones at the failed site will be in SRST mode. All calling to or from other sites must be via the PSTN. In this case, we configure the CFUR destination to be the phone number you would dial to reach the site via the PSTN. For example, to route to Winnipeg via the PSTN, we would use 91204-555-4002. We should take note of the SRND comments concerning routing loops if a phone is unregistered while the gateway associated with the phone's line is still under control of Unified CM. Set the value of maximum forward unregistered hops to DN to 2 to address this issue. For WAN failures, we have the same problem with CFUR as with AAR. We are using the local route group of the last redirecting party. The last redirecting party was at the site where the WAN failed. Attempts to reroute the call will use the gateway at the site where the WAN failed, a gateway we can't reach. Can we fix this like we fixed AAR? No. CFUR and AAR are configured differently. The AAR calling search space is on the calling device. We can direct AAR calls without worrying about local route groups. The CFUR calling search space is on the called party's line. There's no way to direct the call anywhere but the gateway in the called party's local route group. We'll talk about this more shortly. For phones that are not logged in or plugged in, calls to lines can be forwarded to other internal or external numbers, cell phones for example. This can be configured by the user. In the diagram, Winnipeg line 8-602-4001 is forwarded to Winnipeg local number 204-555-1212. Calls to 8-602-4001 will be routed out the Winnipeg gateway. This works fine when using the local route group of the last redirecting party. We'll use the gateway at the site with the unregistered phone. We call forward unregistered Winnipeg line 8-602-4001 to the local Winnipeg 10-digit number 204-273-0000. Now when we call 8-602-4001, we get forwarded to the Winnipeg 10-digit number 204-273-0000 when that's the destination. Success! What should we do? The 10.x SRND suggests we have two options. Voicemail. This works, but we won't show you the tests. And a directory number used to reach the phone through the PSTN for the WAN failure scenario. We surely have a third option, other internal or local numbers. The WAN failure scenario suggested by the SRND won't work unless we stop using the local route group of the last redirecting party. As discussed earlier, that makes call forwarding behavior bizarre and unpredictable for users. We wouldn't do this just so that we can complete internal calls to a site with a failed WAN link. There are other issues with the WAN failure scenario. When the phone is unregistered, but the WAN site is up, calls to the phone will be redirected across the PSTN, where they will surely fail, and we have a loop. If the WAN failure is the result of a router that provides PSTN and WAN connectivity failing, which is not uncommon, calls will again surely fail. The configuration must be permanent. No one is going to rush to reconfigure the CFUR destination after the WAN has failed at a site. Users that can change call forward busy and call forward no answer can also configure CFUR. How do we explain that this value needs to be their own number? For these cases, forwarding to voicemail or a local number will give you a greater chance of success and is easier to explain to users. What should we do? Enterprise 20 abandoned the WAN failure scenario. We will not use CFUR to call across the PSTN to get to a phone in SRST mode. Enterprise 20 allows CFUR to be configured by users for voicemail, and internal or local numbers. We believe that call forwarding to voicemail or internal or local numbers gives you a better chance at completing calls across the range of possible causes for unregistered phones. We use the Enterprise Unrestricted No 911 Calling search space for now. This playbook is continued in Dial Plan for Call Forwarding and Voicemail Integration, Part 4. Part 4 discusses a dial plan for voicemail integration and final fixes for the call forwarding deployment. Thanks for watching, and please subscribe.